Hello students, welcome to my YouTube channel. It is a channel where you'll get exciting video of physics related to Icse class 9 and 10. In my first video, I have discussed about different aspects of sound, different types of sound waves, and at the last of that video, I told that for more uh, concept of sound, different types of wave, or for different term used in the wave, I'll come with a part 2. So it is your sound part 2. So in this we are going to discuss more about the sound. So let's start our video. Today's topic of discussion, sound part 2. Here we'll get more aspects of sound. In our first part, we got two types of wave, sound produced in a medium in a form of wave, which is of two types. One is longitudinal wave, one is transverse wave. Longitudinal wave, which is having compression rarefaction. Longitudinal wave, which propagate with the direction in the direction of propagation of sound. Transverse wave, which move up and down in the form of crest and trough, whose direction of propagation is perpendicular to the propagation of or direction of propagation of sound. Other than that, they are having difference between them, that one is having crest and trough, one is having compression rarefaction. For transverse wave case, there is no pressure variation, density variation, but in case of longitudinal wave, one time we'll get high pressure region, one time we'll get low pressure region. Transverse wave can propagate through solid or liquid, but it is very difficult for the wave to move in the gas. But in case of longitudinal wave, maximum time it propagate in air than in solid and liquid also. Transverse wave time, particles vibrate perpendicular to the direction of motion, but in case of longitudinal wave, it moves parallel to the direction of motion. Light wave is a best example of transverse wave, but sound wave in air is the example of longitudinal wave. So now we'll come to our topic of discussion on which factor speed of sound depends. But before that, as I told in my first video also, that we'll able to know in the second video the term related to wave motion. So first thing to know about different term used in a wave. First term in a wave, if we look, first term used is the amplitude. What you can say the amplitude? Amplitude means whenever the particle vibrate means what? It will move from the mean position to extreme position, again extreme to mean. Means whenever body is moving from one point to another, mean position to extreme position, the maximum displacement, the maximum moment is called the amplitude. That is the distance covered by the particle or it is the distance covered by the wave. So it is having the SI unit meter. Another term used in wave motion is a wavelength, which is denoted by a letter lambda. Here you can see the letter lambda. Lambda is a Greek letter which is used to denote wavelength. And what we can say as the wavelength in case of transverse wave, it is the distance between two consecutive crest or consecutive trough. In case of longitudinal wave, it is the distance between two compression or rarefaction. So the distance traveled by a wave in one time period of vibration of particle is the wavelength. So wavelength means the length of a wave. Depending upon the wavelength, there are different types of waves. In electromagnetic wave also you'll get different types depending upon this wavelength. So wavelength is the distance between two consecutive crest, two consecutive trough, or is the distance covered by the wave in one time period of vibration. So we can say that wave length, which is denoted by lambda, which is having a SI unit meter, the distance traveled by wave in one time period of vibration. Next one in this, we'll get time period. Time period. whenever body is moving or the particle is moving from its mean position to extreme position, how much time it will take to complete the vibration? What is the vibration then? From here it will start the mean position to extreme. Again from extreme to mean. Then again mean to extreme in other end. Then from extreme to mean. For this all total process, how much time a wave will take? It is called time period. The time taken to complete one to and fro movement. The time taken to complete one movement from mean to extreme, extreme to mean in both sides. The time taken by a particle of the medium to complete one vibration as the time taken. So it is in the SI unit second. But how much time it will able to complete in 1 second in unit time in one given period of time is 1 second how much the wave complete vibration, the number of vibration produced in 1 second. Get another term here is the frequency. Frequency is the number of vibration by any particle of the medium in 1 second in a unit time. That is frequency. Frequency having SI unit as Hertz, HERTZ, having the symbol capital H and small z, and the relationship will look between time period and frequency. Frequency is equal to 1 by time period, or time period equal to 1 by frequency, T equal to 1 by F, F equal to 1 by T. Next, in this, we are having a graph. Graph, what is graph? Graph is a pictorial representation between the relationship between two given quantity. So here is a graph between two quantity. One is displacement and one is time. Time in x-axis because the independent quantity and displacement is a dependent quantity. So it is kept in the y-axis. With the time, how much the particle of the movement vary up and down will get in displacement time graph. Here you can see the distance between two consecutive crests or the distance between two consecutive drop. This one is the wavelength which is denoted by a letter lambda. So wavelength is the distance between two consecutive crests or two consecutive drop. So here we get another graph between distance displacement. Distance displacement graph case you can see here, as I told before only, this one the wavelength. This is the amplitude, the maximum upward displacement, maximum downward displacement. That what you can say the amplitude. So here with the time how much the particle of the medium move, we'll get in this displacement time graph. And in displacement time graph here you can see another term used, amplitude, the maximum displacement upward or downward. And with that time we'll get another relationship between displacement time. So displacement time graph and displacement distance graph. And now the factor on which the movement of particle of a body depends. But whenever body will move, when the a body or a particle of the medium is moving from one place to another in a definite direction, it will cover certain distance in a given period of time. That is called wave velocity, the velocity of wave. Velocity means, what is the velocity? Velocity means the distance traveled by a body in a given direction in 1 second. That is velocity, or speed in given direction is called velocity. So velocity, wavelength and frequency. What is the relationship between them? It will come here. Velocity equal to displacement by time. Here the displacement is wavelength. So velocity equal to wavelength by time. But when we'll come here to the symbolic representation, then we'll get that v equal to lambda by t, where lambda is the wavelength, t is the time. That means lambda equal to what we'll get? V into time. So here you can see lambda equal to v into t. And next, when we'll replace or when we'll substitute t as t equal to 1 by f, time period equal to 1 by frequency, so we'll get v equal to f into lambda. So it is a relation between wavelength, wave velocity and frequency equal to f lambda. So what you got in our relation? Wave velocity equal to frequency into wavelength. We can see some numerical problem based on this formula. First one, if we look here, in this formula, in this number, two quantities are given to us. The separation between two consecutive crests of in a transverse is 400 meter, and next one it's given the wave velocity is 20 meter per second. Find the frequency. So what is the thing given to us? It is given to us wavelength, given to us wave velocity. We have to find the frequency. How we can calculate this number? First we take the given part where lambda 400 meter, v 20 meter per second, and how much the f we have to find out. Formula, what is our formula to calculate this number? To calculate this number, we are having a formula v equal to f into lambda, or f equal to v by lambda. So we got our answer 0.05 hertz. It will come to another number, another example. In this, a wave pulse of frequency 200 hertz on a string move a distance 20 meter in 0.5 second. Calculate the velocity and wavelength of wave on string. What is velocity? Displacement by time is the velocity. So to calculate this number, first thing what we'll do, we'll take the formula velocity equal to displacement by time. Here you can see formula velocity equal to displacement by time. So we got 400 meter per second in the answer. And next one to find is our wavelength. So wavelength, how we'll find out? Again, we'll take the formula. Which formula we'll use? V equal to f lambda, or lambda equal to V by f, where 400 by 200 equal to 2 meter in a answer. So like this, we can solve different types of number based on this formula. So here some numerical problem, and you can solve some numerical problem from net or from your book exercise by using this formula v equal to f by lambda, or sorry, v equal to f into lambda, or lambda equal to v by. Time to discuss about the factor on which speed of sound depends. So here we can see whenever sound produced by a source and received by the receiver, it is propagating or it is traveling through a medium. Whenever sound travel through a medium, two factors of the medium on which it depends. One is the elasticity of the medium. How much elastic medium is, how much elastic, because if we look the properties of a medium, in that also we got medium should be elastic, means the particle can move from their mean position, from their initial position, again they can return to their original position. And then next is the density of the medium. Density means the mass per unit volume. So what is the relationship between this speed of sound, elasticity and density? We'll get in this equation. The speed of sound equal to square root of E by rho. Rho, it is a Greek letter used mainly for the density. E by rho, elasticity by density, means speed of sound directly proportional to elasticity and inversely proportional to density of the medium. And here it is a Newton's law. Newton's assume this propagation of sound, or when the sound is traveling through a medium, as a isothermal change. What you can say is the isothermal change. Isothermal change means whenever sound will propagate in a medium, the temperature of the medium remain constant. That is isothermal. Isothermal means when the temperature of a medium remain constant, there is no change in the temperature. That time when there is no change in the temperature, that time elasticity equal to pressure. Means now speed of sound in air equal to square root of pressure by density P by rho. But here the problem comes that by taking pressure and density, or the square root of pressure and density, how much Newton got? Theoretically, an experimental value of speed of sound in air having a huge gap, a large gap between them. That means this law of Newton failed. So Newton's law failed here, and it is corrected by another scientist, it's the Laplace. It is called Laplace correction. So according to Laplace, when sound is traveling in the air, it is an adiabatic change. What you can say is adiabatic change? Adiabatic change means where the temperature of a body, how much, that does not depend. That depends on one factor. There is no exchange of heat. It will not go from one part to another. So, or it is an isolated system. So in that case, sound traveling in air where there is no exchange of heat, we can get another expression for this where you can say elasticity equal to gamma p, where gamma is a constant, is a ratio between Cp by Cv. Cp, specific heat at constant pressure by specific heat at constant volume. So specific heat means what? The amount of heat required to increase the temperature of given mass of a substance by 1 degree Celsius. So V equal to gamma P by rho, where gamma is a constant whose value is nearly 1.41 or 1.4. This is the factor of the medium through which sound propagates. But what are the external factor on which this speed of sound depends? If we look on which factor it depends, or the external factor on which it depends, first is the density. Now only we discussed that it is inversely proportional to density. More the density, less the speed of sound. If we compare between dry air and moist air, moist air having water quantity more, dry air having nitrogen quantity more. Means when the moisture comes to the air, it replaces or it displaces the nitrogen gas, which is having vapor density more. So density of air gradually decrease. So humid air is having less density, dry is having more density. So speed of sound in humid air is more, in dry air is less. Next one, if we look, it depends upon the temperature. In this temperature, with the increasing temperature, the speed of particle increase, their kinetic energy increase, they collide with each other more. So the speed of sound also increase. Here one expression will get here. You can see here we are having an equation. The relationship between Vt and V0, where Vt is the velocity of sound or speed of sound at T degree Celsius. V0, the speed of sound at a given temperature. Here we can see delta T, delta, the triangle symbol delta means small change in temperature, means is the relationship between temperature and speed of sound. With 1 degree rise in temperature, speed of sound increase by 0.61, means Vt equal to V0 plus 0.61, which is a coefficient, which is a constant term used here, or the number used here, 0.61 into delta T, change in temperature. Next one, if we look, is depending upon the humidity. What is humidity? The amount of water or amount of moisture present in a given area is called humidity. More the humidity, less is the density. So less the density, more the sound. So speed of sound is directly proportional to the humidity. More the humidity, more is the sound or the speed of sound, or more distance it can cover in a given period of time. Next one, if we look here, direction of wind. Direction of wind means whenever the wave of sound will propagate or move with the speed of wind, means here the sound is moving from one end to another, the same end air also blowing. That time resultant speed equal to speed of sound in air plus the speed of wind blowing through the uh, medium. Or if sound is coming from one direction and wind is coming from another direction, that time resultant speed equal to speed of sound minus the speed of wind, or speed of wind minus the speed of sound. Means the difference between them will get the actual speed of that sound, means increase or decrease depending upon the direction of wind. And it is not depending upon pressure, it is not depending upon frequency, it is not depending upon amplitude, it is not depending upon any other factor, that it can change the speed of any sound wave uh, which is propagating through a medium. Here, this is the factor on which speed of sound depends. Next one, if you look here, this having the types of wave. Types of wave means sound will produce. Sound, it is a wave. And wave can be of transverse wave or longitudinal wave. All are having amplitude, frequency, and time period. Depending upon the frequency again, this all waves divide into some category. Means which type of sound a human being will able to hear, it depends upon the frequency. That range or to which human ear will persist, human ear will able to hear, that is called audible range. In audible range, you can see it is having a range of 20 Hz to 20,000 Hz. In this range, If the sound will come, then only human being will able to hear. So what you can say 20 hertz to 20,000 hertz. 20 hertz means in 1 second a body will vibrate 20 times, to the maximum it will vibrate 20,000 times. In the middle, between 20 times to 20,000 times vibration in 1 second, human ear will able to persist. I mean, human ear will able to hear the sound. But if the sound will come less than 20 hertz or the sound will come more than 20,000 hertz, that time it is not possible for the human ear to get that vibration. So that two are two types of wave. One is infrasonic and one is ultrasonic. So first one, if we look here, is the infrasound or infrasonic sound with frequency less than 20 hertz. This less than 20 hertz means a body will vibrate less than 20 times in 1 second. So that is 20 hertz frequency, which is infrasonic, which is not audible by human being. Other animals are there which can get this sound, which will able to, or some animals which are having the capacity to hear the infrasound. Another type of sound wave is the ultrasonic or ultrasound. Ultrasound means the sound with frequency more than 20,000 hertz, means a body or a particle vibrate in 1 second more than 20,000 times. It is called ultrasonic. Ultrasonic having frequency high, infrasonic having frequency low. Ultrasound is having, or ultrasonic waves is having frequency high. So it is having number of users, number of application. But first thing we have to know the properties of ultrasound. Why the ultrasound is this much helpful or useful for us? First one, if you look the properties of ultrasound. What the properties or characteristics or character of ultrasound? First one, if you look, energy carried by ultrasound is very high, means amount of energy taken or carrying, or when the ultrasound waves will move from one part to another, how much energy it is having is very high, so that we can get the reflection of sound more. Ultrasound can travel along a well-defined straight path. So when the sound produced by transmitter and receiver will receive that sound, when ultrasonic wave will produce, ultrasonic wave will go in straight path. What is the well-defined straight path? Means when the body is moving in a straight line, it will not deviate towards left or towards right. Deviate means it is a straight line. If it is going any other direction, any side, left or right side, there is deviation. Angle of deviation 0 here. So easily it can go from transmitter and it again can be received by the receiver. So next one is the application where we are using this ultrasound. We are using first one, bats. Bat, when flying from one part to another, will move the leaf, and because the leaf movement of that bat, it produces ultrasonic wave. This ultrasonic wave again pass through the medium, hit to the target and return back. By getting the time of reflection of sound, that will able to know about the location first thing. Second thing is the size of prey. So in the middle, what are the obstacle where the actual prey, that one bat will able to calculate. Next one, if we look ultrasonography and echocardiograph. Ultrasonography means whenever transmitter transmit the ultrasonic wave and will pass through our body. Inside our body, what are the internal disease or the problem of internal organs, we'll able to know by this ultrasonography. And also the growth of baby in mother uterus also will able to know from this ultrasonography, which is having ultrasound report. Ultrasound report usually shows the internal disease. Echocardiograph, ECG. ECG actually used to know the heartbeat of a person. So it actually how much time in 1 minute we'll able to know by this echocardiograph. And any cardiac problem also can be diagnosed easily by echocardiograph. Next one, if we look here, it is used in surgery to remove cataract. Means if there is any unwanted thing in our internal organs like kidney stone and all this, high amount of energy will hit to that target and it will change to powder. That powder easily can be comes out from our body through urine. Means it is useful in our surgery also. Next one, if we look here, it is detection of defect in metal. Inside the metal, if any internal crack, it can be easily detected by the ultrasound or we're bypassing the ultrasound through it. Next one, if we look here, for the cleaning minute objects means some very small dirt can be easily comes out from a body by using high amount of energy of ultrasound. Next one, using sonar, sound navigation and ranging. Sonar actually used to know the depth of a sea, to know the underwater objects. Enemy submarines is used sonar. In sonar, we are having two things. One is the transmitter, which will transmit the sound, which will produce the sound. Second, the receiver, which will receive the sound. The time interval between the transmitter will produce the sound, receiver will receive that sound. And by taking the speed of sound in water, we can calculate the distance of that particular object through which sound reflect, through which sound comes back to the receiver. And here we'll get another type of wave. First one we got ultrasonic, which is having the frequency more than 20,000 Hz. Second one we got infrasonic, which is having the frequency less than 20 Hz. Another one is the supersonic. Supersonic wave produced due to high pressure region, means whenever sound will produce by any object, it gives a high pressure region. That wave produced due to high pressure region is called shock wave. Shock wave having a larger amplitude. Why this larger amplitude? Because of the high pressure. Why this high pressure created in that part, in that medium, in that space? When any object will move with a speed more than the speed of sound in air, which is 330 to 340 meter per second at 0 degrees Celsius. More than that, if the object will move, it gives shock wave, a wave of larger amplitude, a wave which gives high pressure region, which gives a high pressure region because of explosion, moving bullet, rocket launching time. So that all will give a shock wave, and due to this shock wave, produce a wave called supersonic. Supersonic as a term which describes the speed of any moving object having the speed more than the speed of sound in air. So whatever the speed of sound in air in a given temperature, if any object will move more than the speed of sound in air, then we'll get a term for that supersonic. But if speed of sound, whatever that may be, if the object is moving less than that, that is called subsonic wave, means supersonic. Another one, the subsonic. Supersonic is a wave where speed of, if any object is moving with a speed more than the speed of sound in air, and in case of ultrasonic wave, the frequency is more than 20,000 Hz. Both are having amount of energy very high. So this is all about sound and different characteristics of sound, different properties of sound, different types of wave. In our first part also we have discussed some features of the sound medium and all this. In this video also we got about different types of wave, different term used in sound. So this is all about sound. So go through the video repeatedly to know or to understand the concept of sound. So here, next thing is that this channel is mainly for the video of physics. So what you have to do? You have to subscribe my YouTube channel and you have to click on the bell icon for more updates. After going through my channel, first thing to subscribe, then to click on the bell icon for new updates. Like the video, share the video and give your comment in the comment box. You can put some questions also related to this sound and I'll give your answer in the comment box. Thank you. Thank you for watching my video.